Is my screen visible?
Yes.
So yeah, so the sample code was quite problematic, but let's go to it again. C++. Live.cpv. And right. Yeah, so actually this was working, right? Okay. String S2 is Happy New Year. Oh, this, sorry. Okay. So yeah. So despite the, I mean, so that means maybe it's better not to meddle with these things because we are getting warnings. But anyway, so these are legal still. So let me separate these out. Okay. So this works, and so here is the constructor with one argument, which is being invoked here for S1 and S2, and that is fine. Okay. Now, alternatively, so some string y I have given here, we could assign some value to y and also, I mean, yeah, work with it. But the date thing works as well. However, compiler is not very happy with it. So because it says that C++ forbids converting a string constant into cat star. So it's kind of confused between considering this as a string or a pointer of cat. So which is basically how arrays are stored as the beginning of, I mean the beginning of the so a pointer pointing to the initial element of the array is usually stored, and it's showing, I mean, it's suggesting that such a conversion should not be undertaken. Okay, but we don't have an error, so it was all right. So we'll see some more examples of this operator overloading. So we have done binary for mathematical operations. We have done some, yeah, we have done this string operation. Here, what was it doing? Okay, same thing, binary operation between string and string types, and it was creating a temporary object. And yeah, so this was this error was when the total thing would exceed 80, and otherwise it would copy the original object with the object, I mean the string of the original object to the string of the temporary object and concatenate it with the given string. That is fine. Alright, so comparison. So comparison operators, or we can say, well, it's mathematical. Yeah, that's also comparisons are mathematical. So comparison operators, and say so our original distance plus. We'll go back to it. Alright, so this is the zero argument code structure, and we'll have one more. Just mention here. This thanks from user, and our display function. Maybe and finally the overloading the like comparison operator, which in this case will be less than. So we follow the syntax for a binary operation. Feet plus inches. But
Sir,
yes,
is there some particular reason that we always declare operator overloading function as constant?
yes, we don't want. We don't want it to change any value of the objects. Okay, so it is. It
Sir,
is.
but we can take care of that in the function body
Of course, we can.
even if we don't
Yes,
declare it as constant.
we can. We can do that. That is fine.
Like it is not compulsory to declare it as constant, right?
No, it's not compulsory. Okay, and yeah, we return. So this function must return boolean value, and return bf1 bf2 is else false. Yeah, so I'm not very comfortable with shorthands, and so just but one thing we should verify just now. Uh, what happened?
Sir, you haven't saved the program.
Okay, okay, okay. This is fine. Yes. So what we'll do is yeah. So this works fine without the constant. But just to ensure that we do not change anything inside by mistake, even if we do, then we'll get an error. We put the constant here. Okay. So you see, basically this says that if this so what we have done is basically we have kind of like we have converted feet and inches into a kind of fractional notion for feet, yeah, because foot is equal to inches by 12, and we have compared this uh, the distance stored in both of the objects. Okay. D1 and D2, and then the relation between the relation between the distance stored in these two objects has been expressed as an overloaded operator which works between the objects themselves. And let's see here. And here, if now we are using operator between two objects, so it's the overloaded version that we are using. Okay. Let's make this less first. 5, 4.5. This one is okay. What happened? 1 second. This one, okay. Yes, this one is less than these two. That is okay. And the other one, we can say right. So this works. So this was how to overload to comparison. I mean, overload a comparison operator. Let's. So what about comparing strings? Let's go back to our earlier program. I'll just make this 7. So this is right, and we have the zero argument, one argument constructor, and we have the space, the string. So we have to overload. Okay, strings. String comparison is just equal to or not equal to. So we'll just overload the equality notion here, and yeah. Right, I guess. Switch off everything from here. Fine. Okay. So finally, we overload the equality comparison, checking if two strings are equal or not, and that should work on the objects of our new, I mean this user-defined class. So it will again return true or false, right? And yeah, it will be acting to the previous function. And we are using the string comparison from the inbuilt class string to do this. So string 1 is yes, string 2 is no, and we see out. Enter yes or no. We take string 3 from the user. Just let's see. Get string we have defined as with the help of the get function. So it will work on this object. If s3 equal to s1, out you typed yes, then else, sorry, else if S3 equal to S2, Sept you typed and of course there's the possibility that we made some mistake. So yeah, let's see how this goes. Right. This is line 85. Okay. Okay, it works. And then we have in the same spirit of the earlier arithmetic operations, we can check for the arithmetic assignment operators, but that is very similar to what we have done already. So we'll say what about the subscript operator, or shall we do this arithmetic assignment operator? Let's do this serially anyway. Okay, we have sketch on user this space length. This is our comparison. We'll leave this as it is, and we can add, so just this void operator. feet equals to feet plus equals to 82 dot feet. Okay, inches 82 dot inches, and if inches is greater than equal to 12.0, you have to increase feet, right? Inches is equal to inches minus 12, which is basically what this says, and feet plus plus. Okay, we take this here and don't need this much. Right. Fine, we can look at this distance value, and we have taken this one from the user, distance 1. So we can say that we'll add distance 2 to distance 1, and here is the overloaded operator. Then after addition, all right. So this is 6.25, and maybe we'll give 6 and 11.5. Shortest shortest should be more descriptive. We can write it looks good now. Okay. have done the arithmetic comparison and assignment operations. We shall can we do the get and put here? I think I'll let this pass. So we'll come back to overloading at future time. As of now, yeah. So as of now, let's actually stop here. And so we have done some parts of polymorphism. We have seen even function overloading or operator overloading. The next logical step forward would be inheritance, which will start this next week. But yeah, just so can anyone please define inheritance for me? Inheritance in object-oriented programming.
Attributes and methods of some class will be used by its child class.
Sorry.
We will make some a parent class, and that attributes and methods of those parent class will be accessible by its child class also.
So what is the use of
Sir, there exists a easier relationship between the child and a parent.
right? Right. Okay. Yes. So yes, this week we'll start with inheritance, and in your lab, you will basically before you build before you implement inheritance, etc. Polymorphism, you need to build some more functions. Anyway, so the lab will be a continuation of the same type of questions that we have seen earlier. Maybe a little bit slightly different, but not much. You can do with the tools that you have learned before and theory inheritance. Okay then. So, until Wednesday.